Well, hello everybody, and welcome again to another OpenShift Commons briefing. This time, we're really pleased to have Michael Ferranti from Portworx. We're going to be talking today about running databases in production on Red Hat OpenShift, which we're really, this is one of the hot topics. So hopefully we'll get a great overview from Michael today and find out what's coming from Portworx in the future. So I'm going to let Michael introduce himself and take it away, and there'll be live Q&A at the end. But please ask questions in the chat, and I'll try and answer them and save them up for the end. Take it away, Michael.
Okay, great. Well, thanks, Diane. I really appreciate it. I'm excited to be here. Again, Diane introduced me. I'm the VP of Product Marketing at Portworx, and are really excited about kind of all that the community is doing to enable stateful applications to run on Kubernetes and OpenShift. I think Diane is right that this is a really hot topic right now, and we'll kind of talk about some of the reasons for that and some of the industry trends that kind of underscore that. But yeah, I just wanted to start by saying I think the fact that we're even here talking about this topic is an indication of a lot of work that the community is doing around projects like CSI, or the Container Storage Interface, being embedded into Kubernetes and making it a lot easier for users to use different storage options and plug and play. And I just wanted to say a big thank you to all of those in the community who are involved in making those projects a reality. That's kind of the foundation and the starting point for everything that I'm going to share today. I did this talk a few weeks ago, maybe a month ago now. Time flies. Right after the IBM announcement, I was actually at an event in North Carolina at the IBM campus the day after that announcement. And so I was going to take this out because it's maybe not relevant, but I thought, you know what, let me just leave it in and just make one point, which is to say that Portworx as a platform can run anywhere. And that means we have customers who are running in IBM's cloud, IBM Cloud Private. We have customers that are running on OpenShift. And from our perspective, customers make a scheduler decision based on the unique requirements of their app. And Portworx provides a storage layer that works with that scheduler environment. So I know kind of in a time of heavy mergers and acquisitions, sometimes users are concerned about what does this mean for the future? Should I make a choice now? And the point that I'll make here on this slide is simply that Portworx works very, very closely with both IBM and Red Hat. So as a user, you can expect that we will continue to work with both of those companies. And then as with the single organization post-merger, and that as changes are made to application platforms based on kind of what the team, I'm sure, has not decided they want to do yet, but what eventually happens, we will support that environment as well. So kind of, if you pick Portworx, you're picking something that will have a life beyond kind of what we see today in these two companies, will also persist as the companies pull together. Okay, so the title of this this presentation is running production databases on OpenShift, and I'm going to talk about how Portworx enables that. But let's back up a second and just talk about picking the right storage for OpenShift to begin with, because I think one of the things I want to just kind of maybe shed some light on is how Portworx fits into the OpenShift ecosystem, right? There are many different workloads, and different workloads require different types of solutions. I mean, we always want the customer to pick the right solution for the job. So I have two examples to kind of underscore this. The first is to say, okay, what if we have a file sharing and shared configuration use case on OpenShift? Either traditional file storage, or maybe I have a Jenkins environment where I need to share some configuration between my different Jenkins worker nodes. The requirements for that type of use case are typically what we call a shared multi-writer volume, meaning a single data volume that can be accessed from multiple containers, and they all have obviously read access, but also write access to that shared volume. This is kind of just a textbook case of a file storage use case, excuse me. And on OpenShift, the options for this type of use case are really rich. OpenShift has something that's called OpenShift Container Storage, which is based on GlusterFS. You could use something like NFS. If you're running OpenShift in the cloud, as many of our customers are, you could use Amazon EFS. or Azure has a file storage service. There are lots of options on OpenShift for file-based use case. Let's look at another use case, which is databases, and we could extend that to database-like services like queues and key value stores and analytics and streaming. The requirements here are not shared multi-writer, but rather single writer, high I/O and throughput. Okay, just to use an analogy, if I ask you to run Postgres on Amazon, what are you going to do? Well, you're going to spin up an EC2 instance, which is your VM, and you're probably going to attach a block device, an EBS volume to that. What that means is that the storage type for databases when you use single writer and high I/O and throughput is block, not file, but block. And so the question is, what are the options on OpenShift? And, can I use, for instance, OpenShift container storage for these block use cases, specifically for databases? I think the vision there is yes, you can. Today, the Gluster FS team is doing a lot of innovative work around making Gluster work well for block use cases. And there's some primitives in Gluster now called Gluster Block, which is really, really promising. But today, Red Hat is saying that that interface, Gluster Block interface, should only be used for OpenShift logging and OpenShift metrics. And I just wanted to make sure that that was still accurate. And so I just checked this morning. And as of 3.11, that's still kind of the official stance of Red Hat. So, without even getting into, how can Portworx, complement or provide features and functionality that might be different from OpenShift container storage, you're kind of in a situation as a user where if you're following the best practices recommendations from Red Hat, Gluster FS and OpenShift container storage are really for those file-based use cases, not the block use cases. And so this is where Portworx comes in, complementing the other tools within the OpenShift ecosystem with a solution specifically designed for that block storage use case. And Portworx is really proud to be Red Hat certified on OpenShift. We're really proud to be in the Red Hat container catalog, and to partner with Red Hat to provide a single platform that can run all types of applications on OpenShift, including those mission critical databases. And again, this isn't about better or worse or anything that. It's about the particular use case. And Portworx, again, really focuses on that database and database-like use cases, queues, key value stores, big data, streaming analytics, where you need block storage, and you need a kind of high I/O, high throughput, single writer volume. Okay, so getting into a little bit more about Portworx. Here's a slide of some of our customers. The reason I show this slide is because, the breadth and depth of use cases for containers just seems like it's exploding by the day. There are just so many. And the reason I put this slide up is just to say that we have customers across all verticals and industries. We have customers that run on-prem and in cloud, within the cloud that run in all the different clouds, that run in hybrid environments, multi-cloud environments. Some customers run, kind of mission critical SaaS applications in containers running on Portworx. Others are building internal platforms as a service. We've seen all of those use cases. So kind of no matter what angle you come at OpenShift and stateful services, Portworx can help. And, these customers are an indication of all of the different variations that we've seen across the market. Okay, so I want to talk a little bit about kind of some technical problems that Portworx solves, but before doing that, I want to talk a little bit about the business value, right? Why should I even care? Why should I keep listening to this presentation? The first point I would make is that Portworx helps you accelerate time to market for container projects. If you have a microservice or a use case or a platform that requires developers to use databases, queues, key value stores, again, that list of stateful service that need block storage. Portworx is simply the fastest way to get up and running, not only when what we call day one, which is deployment and configuration, but day two, which is what happens when infrastructure needs to be upgraded or servers fail or networks are partitioned, and that app needs to keep up and running. Because Portworx was built from the ground up for containers, as opposed to kind of some other storage systems that were kind of came of age during a time of virtual machines, which don't tend to be as dynamic and certainly were not orchestrated by Kubernetes. Kind of a lot of the complexity is removed because Portworx was built from the ground up to be managed and deployed via those systems. So we've seen customers who have spent a year or more in research and development trying to get various block storage solutions or other storage solutions to work for containers, and then they discover Portworx and are able to get up and running in a matter of weeks. Another benefit would be avoiding vendor lock-in, and I think here, Portworx and Red Hat just have the exact same approach to kind of how to enable applications to run on any environment in a consistent way with choice and without lock-in. We fully support that approach to the market. And so with Portworx, instead of being, say, tied to a single cloud provider, Amazon, because I'm using EBS for my containers, or being tied to an EMC or a NetApp because I'm using all of my data is on that array in my own data center. We support a model where you can deploy Portworx in any environment. And you can move data between any of those environments. So you're not locked into a single physical operating environment, and you're not locked into a single provider. And I would, extend that very transparently to the fact that we are heavily invested in the CSI project I mentioned earlier at the top of the call. And CSI is all about having pluggable storage interfaces. So I would even extend this to Portworx, to say, you're not even locked into Portworx because of those open interfaces that we support, CSI Prime among them, that, if you pick up Portworx and you decide that it's not the right tool for the job, well, then you can move to another solution and not be locked in even at the Portworx level. The last point that I'll make is that kind of in addition to the agility benefits, in addition to the flexibility benefits, our customers see dramatic cost savings from an infrastructure perspective. These cost savings are conservatively on the order of 30 to 60%. And they get those savings both from compute and storage cost reductions. So just one quick example of how that works. We have customers, many customers who run Kafka in production. Kafka is a messaging service. It's very popular with IoT use cases, streaming data and analytics apps. And for a arbitrary level of reliability, based on the SLAs of that application, we see customers consistently, instead of, say, having to run 5 Kafka brokers, which requires 5 containers and requires the CPU and memory to process those containers, being able to run only 3 Kafka brokers, 40% compute savings. And we have customers who are extending that across all of their applications for platform as a service, rather than running a 3-node MongoDB cluster. For the same level of reliability, they can run a single MongoDB pod. And again, get the same level of HA with a third of the compute. That compute savings is really important. It's a little bit counterintuitive because I'm talking about Portworx as a storage solution. How can you possibly help me save on compute cost? Well, I'm going to show you that in a minute, how you can run fewer pods for the same level of reliability, thanks to the way that Portworx replicates data across operating environments. And then from a storage perspective, we help you save money by optimizing the types of storage that you run your applications on. Sometimes this is called tiering. So you have your primary production workloads running on your fastest, typically most expensive storage. You have test environments running on less expensive storage, and then you can offload backups and things like that to object storage. We make all of that very, very easy to do. Okay, so that's a little bit about the why. Now let's get into the nuts and bolts of the Portworx solution itself. So, I mentioned at the top that Portworx is, really supports those block storage use cases. And so, probably won't surprise you at this point to hear that Portworx is a distributed block storage solution. But what makes us unique is our deep scheduler integration. The fact that you can use and control Portworx and manage all of your stateful services running on Portworx directly via that scheduler, in this case, OpenShift, but also native Kubernetes. And you can use Portworx to run and manage any stateful service that requires block storage. So I have 4 good examples here, but we could add Cassandra, we could add MySQL, We could add Kafka, we could add TensorFlow or HDFS. Any stateful service that runs on Linux that needs block storage, you can run and manage via OpenShift with Portworx. And you can do it on any cloud or on-premise data center. And very important in kind of this next wave of cloud and container adoption across all of these environments. And finally, you can do it at up to scales that are consistent with Kubernetes scales, meaning up to 1,000 nodes per cluster. So Portworx scales with your applications. So let's look at a use case to kind of see how some of these key features and capabilities work within an OpenShift environment. So let's say we want to run a highly performant and resilient MySQL database on OpenShift. How would we do that? Well, the first thing that we would need to do is install OpenShift, install Portworx on OpenShift. I mentioned before that Portworx was built from the ground up for containers. What this means is that Portworx itself can be installed and configured and managed via OpenShift. Just like I'm going to manage MySQL via OpenShift, I'm going to manage Portworx via OpenShift as well, which means installing it is ocapply-f and then a YAML file that we help our customers create at a website called install.portworx.com. You can visit that either now if you're into multitasking or after the webinar, and you'll see that you basically put in some configuration options. The IP address of your etcd cluster, or you can specify that you want Portworx to provide a key value store for you, so you don't have to manage it yourself. What type of storage media you're going to be running in. What scheduler you're using. We have some optimizations that we make for OpenShift. You basically, click a bunch of buttons, type in a couple of configuration variables, and you get this YAML file. And when you do ocapply-f with that YAML, Portworx is now installed on your OpenShift cluster. It's kind of anticlimactic. It's so easy. You don't have to do anything on the masters. You don't have to bootstrap the cluster. An individual developer can install Portworx as easily as they would install any other application on OpenShift. From there, we're going to deploy our stateful app with OpenShift. So in this case, we're using MySQL. And the first step of deploying MySQL is going to be creating what is called within Kubernetes a storage class. So using OC create, and then we're going to create a YAML file that has some configuration. So in this case, I'm highlighting that the storage class has a replication factor. Let me back up for a second. So a storage class within Kubernetes defines the type of physical storage you actually want your application to consume when your pod is deployed. You can think of a storage class as a type of storage, and you could deploy applications with different types of storage. So your storage class is a way for you to define, well, what type of storage do I want? You can imagine that a production application would require a different type of storage than, say, a test application. This storage class is very, very flexible. And here I'm highlighting that I want Portworx to create two replicas, to maintain two replicas or two copies of my MySQL volume at all times. This number is configurable and is really important for HA, as we'll see in a minute. I could also specify an IO priority, meaning do I want to, when I deploy my pod, do I want it to land on a host that has an SSD with provisioned IOPS? Or do I want it to land on a local disk? Or do I want it to land on a block device with that's using HHDs for lower cost? I can specify that. And importantly, I can also specify things like snapshot policies as well as encryption policies. So if we look at kind of tiering between kind of architects and administrators and developers, architects and platform operators can specify storage classes that developers should use that will automatically apply things like snapshot policies, say back up this app once an hour, or encryption policy, so that my developers don't have to think about that kind of security and business continuity, but I can as a platform architect, but it's just really easy for them to use Kubernetes to deploy their applications. All that's done through the storage class. Once I have that storage class, I'm going to create a PVC that references that storage class. I'm going to create a deployment within Kubernetes, and then all of a sudden, I have deployed MySQL using OpenShift with Portworx providing a persistent volume to my MySQL database. From here, we start to see the features and capabilities that enable Portworx to make that database highly available, highly resilient, and easy to manage, even when it has mission critical data. And now we're going to look at some of those capabilities. So the first is, if you remember back to that storage class, we had created a replica, or we had said we wanted to have two replicas of our data, two copies of our data, excuse me. So here, once that pod is deployed with that storage class, Portworx is automatically going to see that, oh, we need two copies of this data. So I'm going to create a copy of it. And importantly, I'm going to place it on some other node in my cluster. And Portworx does that in what we call a topology aware manner, meaning that if you're deploying OpenShift on Amazon, we understand the difference between availability zones. And so when we see that your Kubernetes cluster spans availability zones, we're going to place your replicas across those availability zones as well. So that if I lose even an entire availability zone, Kubernetes and OpenShift can automatically fail over those pods to that other availability zone. And we're kind of maximizing the HA of our application thanks to our network architecture. And looking at what that looks like, if we lose that node 3, OpenShift is automatically going to reschedule that pod to another node in our cluster. We can see we have node 1 and we have node 2. Portworx can tell Kubernetes where to schedule that pod based on where the replica is. The idea of running a pod and on the host that actually has a local copy of the data, that's called hyperconvergence. And many modern databases, Cassandra and Kafka being great examples of it, but also Postgres and MySQL, tend to perform better when they're running close to their data, when they don't have that network overhead. And so it's one of the key things that Portworx does is we can instruct Kubernetes where data volumes live, such that when it reschedules a pod to another host in the cluster, it lands where the data is versus on somewhere where the data does not live, and you would then be forced to go over the network. So we ensure that hyperconvergence even in the case of failover. Other examples of day 2 operations that Portworx facilitates would be Cloud Snap, which is a feature of our platform called PX Enterprise for offsite backups. So, day 1 operations, deployment and configuration, we saw that. On day 2 operations, we start to have to think about failover and high availability. We also have to think about backup and recovery. We could call it DR. We call it backup and recovery. We could call it business continuity. Whatever you want to call it, you need to have a copy, an up-to-date copy of your application running in some other environment. So Portworx makes that easy with something we call Cloud Snap, where you can basically snapshot either a single volume, a namespace, or any arbitrary group of volumes, move that data to an object store, either running on premises, maybe you're using Minio, maybe you're using Ceph, and then restore it to another region, and redeploy your pods, and now your app is up and running again. Kind of a very easy to use, intuitive, simple snapshot, move, restore functionality. And I'm going to get into in a minute of some new capabilities that we've launched to make this even simpler. But this is a good starting point. We also support bring your own key encryption. So security has never been more important than it is now. And it's really important that we enable our customers to follow security best practices. So one of the things that we enable is bring your own key encryption, meaning that even Portworx can't decrypt your data, only you have those keys. And those keys can be at the container granular level, meaning you don't have to encrypt your entire Kubernetes cluster with a single key. You don't even have to encrypt in a namespace with the same key. You can encrypt each of your individual data volumes with the same key. And even when you back up, even when you migrate those applications, they're going to maintain that key. And we support all of kind of the major key management systems. So I kind of alluded to some new features related to data migration in the last slide. I want to kind of wrap up a little bit talking about some of that. So just yesterday, we released Portworx Enterprise 2.0. Portworx Enterprise 1.0 is really the foundation of what I just shared with you. It's that, ability to run and manage mission critical databases in containers managed by Kubernetes in ways that both, individual developers know and love, and IT ops can manage effectively and fit in with their existing business practices. In kind of working with the customers that I showed on the previous slide and many others during the few years where PX Enterprise 1.0 was in the market, we learned a lot about kind of, where are customers going next? Clearly, as a community, we think that container adoption is only going to increase. The kind of the consolidation, we could call it, of the market with IBM acquiring Red Hat, with VMware acquiring Heptio, and others, we see that containers are here to stay in the enterprise. And container platforms themselves are going to be used not just to kind of speed up the development process, but to really bring hybrid cloud and multi-cloud operations into the mainstream. My personal opinion on why IBM purchased Red Hat is that OpenShift gives it a great way to compete in the cloud market. The public cloud market is a really tough business. And IBM launched a public cloud, and it wasn't as successful as Amazon and Microsoft. That just the market numbers are categorical on that point. But IBM knows how to run applications, knows how to manage data, and is trusted in the enterprise. So how can if IBM knows that enterprises want to move to the cloud, how can it have a play there? And I think its play is OpenShift. In commoditizing the public cloud providers as simply a place that I'm going to run OpenShift. I run OpenShift on Azure, I run OpenShift on Amazon, but really the value provided to the enterprise is at the OpenShift layer, which means you need to be able to solve the data mobility problem. If you're really going to do hybrid cloud, if you're really going to do multi-cloud, you have to solve the data mobility problem. And this headline from the news stack just yesterday, I think really underscores why we launched PX Enterprise 2.0. We do believe that hybrid cloud is probably the biggest trend in enterprise IT right now. I think it's only a matter of time before all enterprises are operating in their own data center, as well as a variety of public clouds. We're already seeing it. We did a survey where we saw that a third of respondents are already running in multiple clouds, and we think the next 2/3 of that over the next couple of years will be as well. And so that's why we launched PX Enterprise 2.0. So how does our 2.0 release help enable hybrid cloud? Well, the way that we do that is by solving data mobility. And the feature that solves this problem is called PX Motion. And if you're been in and around VMware for a number of years, this might sound familiar. VMware has a concept of vMotion, and the fact that we call this PX Motion is not it's not by chance. It's also don't take that analogy too far, and I'll explain exactly what it is. But we wanted something that kind of had some of the same ideas that vMotion brought to the market from VMware, and the ability to move VMs and data between environments. We wanted to bring that and update it and modernize it for containers. So we have PX Motion. What does PX Motion do? In a nutshell, PX Motion allows you with a single command, again, that ubiquitous kubectl apply or OC apply, to migrate data, yes, between environments and clouds, but also pods, controllers, objects, volumes, HA levels, and policies. Your entire, what I would call, application stack between environments with a single command managed by Kubernetes and OpenShift. That's what we wanted to do. And so what Portworx did is we leveraged some of the capabilities within Kubernetes, in specifically its concept of scheduler extenders, to be able to, we can already migrate data. We saw that earlier. We can very easily snapshot and move data between environments. We can do it at an application consistent level, and we can do it for groups of volumes. But that still requires you to spin up your pods in another location and point to the right data volumes to get your app up and running. We said, how can we make that a one-click process? And so that's what PX Motion has done. You do kubectl apply, and you describe your migration, your source cluster, your destination cluster, which objects to move. Kubernetes moves your pods, your controllers, and your objects. Portworx moves your volumes, your HA levels, and your policies. And so in a single command, you're able to migrate between environments. Now, what does that enable? One of my last slides is a little bit of a few use cases for PX Motion. One is augmentation. It's simply the idea that, as an application architect, I'm building a platform that has some notion of capacity planning, right? I'm expecting a certain number of applications to run on my platform. And as we all know, sometimes the best laid plans are for naught. So sometimes apps are more popular than we would expect, and we need to augment our compute capacity in order to handle those additional applications. Sometimes what that means is taking an application and moving it to a cluster with more capacity, or maybe we keep our high performing application on the same cluster, and we want to move the lower performing application to another cluster. There are multiple ways to free up compute capacity. Portworx enables this. You can basically select applications. That could be an entire Kubernetes cluster. It could be a single namespace. It could be a single pod. And again, we allow you with a single command to migrate the pods, the configuration, and the data between clusters. Another example is blue-green deployments for stateful services. Here, let's take an example of a MySQL database. Unfortunately, yesterday, there was a kind of a critical CVE for Kubernetes where basically everybody had to upgrade to a patch version of Kubernetes. Kubernetes makes upgrading Kubernetes easy, but when you're running an app in production, you need to qualify that new release for your applications if you don't want to have kind of unexpected errors that occur. A very popular way for rolling out new versions of software within DevOps is blue-green deployments. I won't get into kind of the best practices for blue-green. I will suffice it to say, Portworx with PX Motion allows you to take your application running on Kubernetes, create a second copy of it, including pods, including configuration, including data, move it to some other cluster where you can then run your tests and decide whether you want to flip your load balancer to that new green cluster. We make that very, very easy. So the timing yesterday was unfortunate. Anytime you have a critical security vulnerability, it's unfortunate. But it really underscores why once you start running databases in production on Kubernetes, you need to be able to very quickly qualify those apps on new clusters, and PX Motion helps you with that. The final example would be, simply just better test dev. A lot of bugs that happen are a result not just of code, but of the interplay between code and data. So Portworx helps you debug better by, for instance, taking a snapshot of your production data, moving it to a test environment where then you can run all of your tests. You can debug. You can see whether or not it was the combination of your code and your data that led to that regression, and so you can fix it. These are some examples of the utility of PX Motion, which again is the ability to move both pods and configuration and data between environments. Okay, we're getting to the end. I'm happy to answer questions now. Just a couple of resources for you, and we'll be sharing these slides so you'll be able to have access to this. These are some hyperlinks. We have a lot of content on our site about running databases on OpenShift. So here I have a blog about MySQL. Here's one about MongoDB. We have a demo of running databases. Kind of the first part of the presentation is similar to what we did today. The second part is actually a live demo via the OpenShift command line for running MySQL on OpenShift. So you can take a look at that. This is a demo video. And then if you're interested in learning more about PX Enterprise 2.0, we have a blog post that we did about how to run blue-green deployments, kind of some of the overview and the why and the how of PX Enterprise. And then, of course, if you want to learn more about Portworx, please visit our website. You can go to portworx.com/request-a-demo. We're happy to kind of talk to you specifically about the apps that you're running, specifically about your operating environment, and to see if we can help you do more with your OpenShift platform. And with that, I will happy to answer any questions you have.
Awesome. Thanks, Michael. There is one question about PX Motion and how it works to guarantee that there's no loss transaction, or if that is the application's responsibility. Shane is asking that, and I'll unmute her to see if
Yeah,
she has.
no, yeah, it's a really good question, and it's kind of a multifaceted answer. So the first thing is that when it comes to snapshots, Portworx has the ability to create what are called application-aware snapshots. Meaning, if I have a multi-node, say Cassandra cluster, Portworx can actually snapshot all of those pods running on different hosts at the same time by quiescing the Cassandra in kind of a Cassandra specific way. And it's different for how you would do it on Postgres, how you would do it on Mongo, how you do it on MySQL, how you do it on Cassandra. So we actually have that application specific logic built into Portworx. And it's extendable to even custom applications that you write and maintain yourself. There's basically a kind of pre-hooks and post-hooks that you can configure to run the right app level commands before those snapshots happen. And so there you're always going to get application consistency. The question here is from a transaction perspective. So we don't migrate memory state. So depending on the type of application and what you're trying to do, there may be application level work that you need to do in addition to the app level snapshots that Portworx would handle.
Okay, thank you. So what you're saying is the type of PV or PVC will have the awareness of what kind of database or what kind of application is running?
Yes, that's correct.
That's okay. That's interesting. So this is kind of, I'll try to comparing that in between the container native storage versus the one you have. And for the CNS, it's more on the infrastructure side. We are application agnostic. Basically, we don't care what application, and the application takes the responsibility. And I'm comparing what the additional capabilities you guys can do, right? And so for when you're saying the pod, you also snapshot the pod information, including the one is not in the PV information. You know, when you're running a pod, you will have some data for your application that you want to write it to the persistent volume, and there's data might be just in the pod. And you're saying that you're gonna the product itself has the capabilities to snapshot everything, or just the information in the volume?
Yeah. So if the pod is not using a persistent volume, when the pod would basically be restarted in a new
right.
In a new environment.
I understand that part. So that means that the snapshot is only snapshot the storage part of the volume data.
That's
only
correct.
The data in the volume.
The
Okay.
snapshot is the data in the volume.
So I would imagine there will be some kind of specific requirement how to make that transaction to work. Like there's some prerequisites maybe then that it will aware of how the transaction, how to cooperate with the transaction. I'm just curious. I don't know if that even a relevant question. Because we're talking about around transaction, right? Because when we deal with database, there's a lot of transaction between in different times. So when we're doing PX motion or snapshot, we'll have to consider how the transaction at a given time, and if we will lose the transaction, we will doing that, right?
Yeah.
When we
So
fail over and stuff like that.
yeah, it's a great question. So the way that Portworx solves this is using what's called a scheduler extender within Kubernetes. So we have a scheduler extender that's called Stork. And Stork is where this application specific logic is. So I know that, for instance, if I want to snapshot my Postgres database, I want to make sure that any in-flight transactions are written and acknowledged before I take that snapshot. Otherwise, you're right, I'm going to lose that transaction. I snapshot it right before that order came in, or I'm going to have told the user that your purchase has been successful, but I'm not going to dock it in my inventory system or something like that. There, some ways in which a lock transaction would affect it. So Portworx understands Postgres, how to flush right here, through the scheduler extender. And again, this is extensible to any database. It's using basically pre-hooks and post-hooks. So different database tools have different ways to issue those commands, whether it's PG tools for Postgres, whether it's node tools for Cassandra. PX Enterprise understands those application level semantics.
Okay. Very good.
Yeah.
Thank you.
You're welcome. That was a good question.
Yeah, thanks, Shana. That's probably a deeper dive than I expected to get out of this. So that was awesome, and I certainly did. I wasn't aware of the PX motion. I did put into the chat the link to the announcement that came out yesterday, I think, or the blog post there. So I'll add that in for those of you listening to the posting of this recording on YouTube and on the blog post on OpenShift.com, so that you can read it as well. So it's a very a robust solution for a lot of these things that I wasn't quite aware of, what you were doing with CloudSnap. So I'm very pleased that you took the time today to do this. I know that Portworx is coming to the OpenShift Commons gathering next week in KubeCon, so they'll have a table there, and I'm sure we can ask some more questions there, and I expect that you're probably also going to be at KubeCon itself. So
we will.
There's lots of opportunity here to get more hands-on and deeper on this topic, and I'm sure as we go forward, there'll be new releases of this as well. So we hope, Michael, that you and your colleagues will come back and do more talks on this topic, because I think it's quite interesting as we go in, as the landscape keeps changing, how we have to deal with all of this, the data storage and the data mobility questions.
Yeah, absolutely.
Some of the other, I know at the gathering, there's one of the talks is about sustainable data centers with Vattenfall, and they have been asking a lot of questions about specifically this topic. So I hope we can connect you with them, and that will be that would be very interesting to see if we can get the two of you talking next week. So make sure that I do the intros there. And, this is, as always with the briefings, sometimes it leaves us with more questions. But if you have questions, please do reach out to Michael and the team at Portworx. And they are also available in the chat on OpenShift Commons, and you can ping them there. But we'll be putting this up on the blog. And any final words, Michael?
No, just thanks again. I think we're big fans of Red Hat and really like the open ecosystem that you create and kind of the choice that you give your customers. So when it comes to their databases, we would love them to give us a look, and happy to answer any questions. And we're also really transparent. If it's not a fit or there are better solutions, then we'd much rather the customer be successful, and then for the next project where they do need something like Portworx, to work with us there. So if they have kind of questions about architectures and things like that, we're always happy to help them, figure out what the best way to architect is. And yeah, we'll see hopefully a bunch of people next week.
Yeah. Well, I think in a hybrid world that we're all moving to, Portworx is one of the essential key pieces. So it's great to have you as part of the system, ecosystem as well. So take care, everybody. And thanks for your questions, Shana. And we'll talk to you all soon and in person.
Thanks. See you, everyone. Bye.